will see the moment of inertia of T section. So numerical, determine the moment of inertia of the T section shown in figure about its centroidal x-axis and y-y axis. So this is the figure. Total height of this T section is 200 mm and width is 200 mm, and flange height is 50 mm and wave thickness is 50 mm. Now here ask about the centroidal x-axis and centroidal y-y axis moment of inertia. So first we have to find the moment centroid of this T section. So solution. So x bar and y bar is nothing but the centroid of this T section, and x bar is how to calculate, that is summation of xa divided by summation of y. You can refer my previous video to find the centroid of any section. So in another way, x bar is find the a1 x1 plus a2 x2 divided by a1 a2. a1 and a2 are the areas which we can divide this T section into two standard shape, that is two rectangles. Then y bar is summation of ya divided by summation of a. In another way, y bar is, we can find the a1 y1 plus a2 y2 divided by a1 plus a2. So this is the T section, and for to calculate the x bar and y bar, we have to prepare here the table. So first area is divide, you can see in the figure, that is this is a1. This a1 is width is 150, sorry, height is 150 and width is 50, that is 7500 mm square. Then a2 area is 200 width and 50 mm height is there, so 10,000 mm square is the area. Then locate the x1 and x2 distance. So x1 is how to find, first we have to find the centroid of this a1 area, centroid. This is the G1 is the centroid of a1 area. Then from left edge, there is x1 is distance is there. So x1 distance is from the left edge, that is 100 mm. Then x2 is G2 is the centroid of a2 area. Then from G2 to left edge, that is 100 mm, again x2 is there. Then y1 and y2. y1 is from lower edge to the centroid of this first area a1, that is y1 distance is there. y1 distance is 75. Then y2 distance from lower edge to the centroid of this second area a2, that is 175. Then take the multiplication of this a1 and x, this is 7.5 into 10 raised to 5. Then a2 into x, a2 into x, that is 1 into 10 raised to 6. Then similarly do the multiplication of a1 into y, a2 into y. Then this is the 5.6 into 10 raised to 5 is first multiplication, y into a, and second multiplication is 1.75 into 10 raised to 5. Then area, take the addition of area, this is 17,500. Then take the addition of this xa, that is 1.07 into 10 raised to 6, and second addition is y into a is 2.31 into 10 raised to 6. After preparing this table, we have to calculate the x bar and y bar, and then mark the x bar y bar. Then x bar, put the value of a1 x1 a2 x2 divided by a1 plus a2, and after putting, take the division of this, that is after taking the division 100 mm is the x bar. Then y bar is after putting the a1 y1 a2 y2 and a1 plus a2 value, take the division of this, and y bar is 132.14 mm is the y bar. Then after calculating the x bar and y bar, we have to mark the x bar and y bar in the diagram. This is a T section. So first mark the x bar and y bar is, we denoted here the g, this is the x axis and this is the y axis, and we have to mark the x bar. This is x bar is 100 mm from left edge, and from the lower edge this is the y bar 132.14 mm. So after marking this x bar and y bar, this is a horizontal x axis is the centroidal x axis and y is the centroidal y axis. So we have to find the centroidal x axis and centroidal y axis moment of inertia. So for that we apply here the parallel axis theorem. So for parallel axis theorem you can refer my previous video of this parallel axis theorem. So first, centroidal x axis moment of inertia, we have the two sections A1. So here we have the two areas A1 and A2. Then we can add this moment of inertia of first area A1 and A2 about the centroidal x axis. So Ixx1 plus Ixx2. So Ixx1, here we have the standard shape A1, that is rectangle, and A2 is also again rectangle. So again we simplify or we apply the parallel axis theorem to this. So first, moment of inertia of centroidal x axis of area A1 is Ig1 plus A1 yc square plus Ig2 A2 yc square. So Ig1 and Ig2 are the moment of inertia of its own centroidal axis. So apply this, and here Ig1 is nothing but the moment of inertia of rectangle. Rectangle is BD cube by 12 plus A1 area, and here yc square for first section A1 is y bar minus y1 distance plus BD cube by 12 plus A2 area into y bar minus y2 bracket square. So after putting all the values, we will get the Ixx is nothing but the 5.9 into 10 raised to 7 mm raised to 4. So this is the centroidal x axis moment of inertia. Whenever you take the centroidal x axis moment of inertia, then take the y distances, and whenever you take the y centroidal axis moment of inertia, then take the distance of x. Then here we have to find the moment of inertia about the y axis. So here you can add the A1 plus A2 moment of inertia. I have Iyy1 plus Iyy2. So Ig1 plus A1 yc square plus Ig2 A2 yc square. Again simplify it, and putting the Ig1 value BD cube by 12 plus A1 into x bar minus x1 bracket square plus BD cube by 12 plus A2 x bar minus x2 bracket square. Put all values in this equation and we will get the value of Iyy 3.48 into 10 raised to 7 mm raised to 4. So in this way we can calculate the any T section moment of inertia about the centroidal x axis and centroidal y axis. Thanks for watching. We will meet in next video.